All right, it's time to do our test review for Unit 2. Look at all that you learned in Unit 2. You found the surface area and volume of a prism, the surface area and volume of a pyramid, surface area and volume of a cylinder, surface area and volume of a cone, surface area and volume of a sphere. Then you also determined the changes in perimeter area, surface area, and volume in common figures and solids when one or more of the lengths has changed. And you learned about finding the surface to volume ratios. And you learned to identify these figures and their parts, which is prisms, pyramids, cylinders, cones, and spheres. So you learned quite a bit. And also, do you have a copy of the geometry formula chart on your desktop or other handy location? If you do not, you can find one in doc sharing of your LMS because you're going to need it for the test. And here's what the chart looks like. We're not using much of anything that's over here on this side. Mainly what you're going to be using for your test is all right here. Oh, let's look at these prisms. All I did was I kind of went through and said, hey, here's your lateral face, this right here, of a triangular prism. Here was a rectangular prism. And look how I've taken all the bases. Got them all pointed. So you got triangular, rectangular, cube, pentagonal, hexagonal. I also am pointing here for a base edge. It's not just going to be a base edge on a cube, it's on all the figures. And then here I'm pointing, giving you an example of a lateral edge. You're going to need to know all of that. Identify these figures and their parts, blah, 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 blah. Okay. Triangular prism, 5 faces, triangular base, 9 vertices. Okay. And you've got to be able to figure that out just by looking at the pictures. But I go through and I talk about these for each one of the different shaped prisms. Be able to calculate these for any prism, pyramid, or cone. I'm just giving you the prisms here as an example, but you need to be able to do it for any of the shapes. There is already a copy of these slides in doc sharing, so you can go in and have them go through them slower than what I'm going through them in this recording. Find the surface area and volume of a prism. If you look on your formula chart, here's the surface area. Here's the volume. Okay, and depending on the shape of the base, you may need to know the formula for a triangle, rectangle. You're not going to need rhombus, but a trapezoid and a regular polygon. Those are all going to be your capital B's. Let's take a look at pyramids. Remember, your slant height is always that lateral edge. This orange right here is your lateral face. And then down here, this pentagon is going to represent your base. And your height is always going to be perpendicular to the base up to your vertex, unless it happens to be an oblique. Here's how you're going to find the formulas for surface area. Here's your formula. Remember, capital P is perimeter, capital B is the area of the base. Here's your one for volume, 1/3 the base times the height. And remember, your pyramids can have different shapes. So here's the different shapes that formulas you're going to need to know, with the exception of rhombus. You won't need it. And I also put this, do not confuse the height with the slant height. Remember, your slant height goes down a lateral edge. Your height goes from your vertex perpendicular to your base. Cylinders. Here, your base is always a circle with the cylinder. Here's your lateral face, the height of your cylinder, and then here's your radius. Surface area of a cylinder, right here's your formula. And remember, take the 2 out, pi RH, that's just area of a rectangle. Because remember, if you lay this out flat, it makes a rectangle. And then Pi r squared is the area of a circle. You've got two circles, so you got to multiply it by 2. Don't forget that radius is half of your diameter. If you're given the circumference, use the following formulas to determine the diameter or the radius. On your cones, here's your slant height. This triangular looking figure right here is going to be your lateral face. Here's your radius. Your base of a cone is always a circle. I don't know if I said it already, but that's your slant height. Your height is always going from your vertex perpendicular to your base. In the right cone, this is also known as your axis. So here is the surface area for a cone. Here's your volume for a cone, which is also the same as a pyramid. Remember, radius is half the diameter. Just like with your pyramids, don't confuse your height with the slant height. And again, use these formulas to figure out your radius or your diameter if they happen to give you the circumference of the base. Here's spheres. Not really that much you need to know. It's a big circle, solid, like a basketball. Your diameter goes through the center from side to side. Your radius goes from the center to a side. Here's your surface area formula. You're just going to take the surface area of a circle, multiply it by 4. Here, your volume is 4/3 pi r cubed. Remember, radius is half your diameter. And again, if they give you the circumference, you can use these formulas to find your diameter or radius. Effects of changing dimensions. Here is a rectangle that's 6x4. Here's a rectangle that's 6x8. It says what happens to the area and perimeter when you double the length of the rectangle. Notice how they've taken this 4 and they doubled it to 8. The area is going to double. So if you double the length, then your area doubles. The same would happen if you tripled one of the dimensions. The area would also triple. So see, they took this 6 and they doubled it. They took this 4 and they doubled it. I don't think that's supposed to say triple. I think that's supposed to say doubled. So what if both dimensions were doubled? When both dimensions are doubled, the area quadrupled. It doubled twice. The perimeter doubled as well. Okay? So here's an example. A rectangle has a perimeter of 50 meters and an area of 150 square meters. A says if you triple only the width, what is the area of the scaled up rectangle? Here, I'm just read that again. If you triple only the width, what is the area of the scaled up rectangle? Remember, this word triple right here is our multiplier. So our new area is going to equal our original area multiplied by 3. Our original area is 150. 150 times 3 is going to give us 450 for the new area. Now if you look, if I've tripled only the width, then my area is going to triple. If you triple the length and width, what are the perimeter and area of the scaled up rectangle? Well, to get my new perimeter, I'm going to take my original perimeter multiplied by 3, which triple is my multiplier and it means 3. So my original perimeter is 50, my multiplier is 3, so my new perimeter would be 150 meters. I'm going to take my, to get my new area, I'm going to take the original area times my multiplier, which is 3, and this 2 should say squared. Okay, so it's going to be 3 squared. So I'm going to have 150 for my original area and then 3 squared. And that's going to give me 1,350 square meters for my new area. And there I just wrote it out all verbally. So now we're going to turn to solids. This time the length of the cube is doubled. The figure becomes a rectangular prism and the volume doubles as well. So look, I've got a cube and all the edges measure 4, but the length is going to be doubled. So notice how my volume doubles. Now if you tripled one dimension, the volume would triple as well. Consider what happens when 2 dimensions and 3 dimensions are doubled. So look here, I got my cube, and here I doubled my length and I doubled my height. My width stayed 4. Down here, I doubled all of my dimensions. It says when 2 dimensions are doubled, the volume quadrupled. See how it went from 64 to 512? Or doubled twice. When 3 dimensions were doubled, the volume became 8 times greater, which is the same as being doubled 3 times. I think I mispointed, but y'all can look how it went from here to here, and it quadrupled. Okay, it went from 64 to 512, and it became 8 times greater. Okay, so I have a right rectangular prism has a volume of 480 cubic meters. What is the volume of the new prism if the length of the original prism is doubled? So remember, my multiplier is going to be doubled, which is 2. My original volume is 480 multiplied by 2. So my new volume is going to be 960 meters cubed. Remember the surface to area ratio. This is what the fraction looks like. And here's the formula for finding the surface area of a cube. Here's the formula for finding the volume of a cube. So I can take, I can eliminate. You've got to remember how to do this with your exponents. You say 2 minus 3 would give you a -1, so that leaves you the s. So all they did was simplify that fraction. And then they said compare the ratios of cubes with lengths of 2, 3, and 6. So here's one with a length of 2. They replace the side length with 2. 6 divided by 2 gives you 3. This one was a side length of 3, so they replaced the s with a 3. 6 divided by 3 gave you a ratio of 2. And then when you replace if you got a side length of 6 and you replace the s with a 6, then you're going to have 6 divided by 6 gives you a ratio of 1. There's going to be a 1-to-1 ratio. And it says, notice that as the side length increased, the surface area to volume ratio decreased. This is true for any solid. The surface area to volume ratio is inversely proportional to the size of the solid. So I gave you some examples here of finding the surface to area ratio. You've got this triangular prism here. We're going to have to find the surface area of it. Okay? So remember, capital B is base area. My base is a triangle. Capital P is perimeter of the base, and here's my base. Okay, it's a triangle. Right triangle to be specific. Okay, well my formula for a right triangle is just to find the area. It's going to be half the base times the height. And so this right here I've called 8 my base, 6 my height. So that's how I plug those in. And then I've got my perimeter is 24. Well, you wonder how I figured that out. If you look here, let me get this side right here is 8. This side right here is 6. This side right here is 10. But what might confuse you is they actually wrote it up here. So anyway, if I say 6 plus 8 plus 10, I'm going to get 24 right there. And then the height of my prism is 5. So what I did here was I just did all the math. 48 plus 120. So I got 168 for my surface area. Now for my volume, remember the capital B I've already figured out right up here. Okay, if I say 1/2 8 times 6, I'm going to get 24. Well, why don't I just go ahead and plug in the whole formula just like I did before. And then 5 for the height of the prism. So I get 120. So my surface area to volume ratio is going to be 168 over 120, which reduces to 7/5, or you would say 7:5 ratio. And that was my last slide. So that was a pretty good solid review. I also want you to be looking at the review. I believe this is 217. Look at all the problems that they have for you in the LMS lesson review. And good luck on the test. Thanks.